So today we are going to solve a problem to check if a tree is a binary search tree. So first, what is a binary search tree? So if you look at this tree, right? So for a binary search tree, the root is always greater than the left node and is smaller than the right node. So how do we check? Like, what is the pattern that we need to consider? So if you see 50 is greater than 30 and 50 is lesser than 70. Same 30 is greater than 20 and 30 is lesser than 40. Same 60 is greater than lesser than 70 and 70 is lesser than 80. So for every node, this property up until leaf should be true. Okay. So the property that we need to consider is the in-order traversal. So in-order traversal of a binary search tree is always sorted. So what is in-order traversal first? So how do we calculate the in-order traversal? So like we can draw something like these lines, and we need to follow this path. So we start from the most left node and go like this. So first will be 20, then will be 30, then it is 40, then it will be 50, then it is 60, then 70, then 80. Okay, so if you look at this clearly at this in-order traversal, it is sorted 20, 30, 40, 50, 60, 70, 80. So in-order traversal of a binary search tree is sorted. So the goal is to calculate the in-order traversal and then check if it is sorted. And simple, we can check, like we can loop through this in-order traversal and compare each element with this previous element. And if it is at any point of time, this array of I is let's say lesser than array of I minus 1, then it is not BST, otherwise it will be BST. So first we will calculate how to find the in-order traversal, then we will check if the in-order traversal is sorted. So how do we find the in-order traversal? For that we need to perform the depth first search. So now our goal is to write a DFS method which will do the depth first search and find out our in-order traversal. So let's define our function. I'm going to write the pseudo code and it can be written in any language. So let's say our function is definition DFS, and it will take the root node of the tree. So it will take root, and the base condition is will be when our root becomes none, then we will return. So if root is none, then return. Okay. Now next we want to go to the left of our current node and then go to the right. But before going to the right, we will print out our element value, or we can add it to an array. So let's assume we have an in-order array list where we will store our in-order traversal, and this is a global variable. So we can do something like so again do the recursive call to the left, then store the current value inside this array, in order array dot append. Let's say, because I am doing in Python, you can do the same in any language. Add root dot value, and then we go to the left. So do the DFS root dot right. So we went to the left, then in order traversal, added the current element, and then went to the right. So finally this will do the DFS, and it will give us it will give us the in order traversal, which is nothing, as we discussed, 20, So final the value of in order will be, in order will contain 20, 30, 40, 50, 60, 70 and 80. Okay, now we need to write a function to check if this in order traversal that we have got is sorted or not. So we can simply write a loop. So for I in range 1 to length of our in order traversal. Why are we starting with 1? Because for this condition check, when we are checking our current element value is greater than our previous element value, and we are going to write this condition in order I is less than in order I minus 1. Here we are doing minus 1. So if we start with 0, then it will throw index out of bound exception. That's why we are starting with 1. Then we return false. Why we return false? Because at this point the condition has become false, which means this array is not sorted. That's why we are returning false. And if we are able to complete this whole traversal without any issues, without this condition getting triggered, then we can return true. So this is how we are going to check if a given tree is a binary search tree. First, do the in-order traversal of the tree and find out the in-order traversal array, and then loop through the array and check if this every element is always greater than the previous element. Then it is a sorted BST.